just to introduce myself, I am Reverend Richard Gaub. I'm a middle school teacher at Memorial in Houston, Texas, and I teach religion, math, literature, grammar, and whatever else Pastor Paul tells me to teach. So you are here for a session on math. If you're in the wrong place, tough. You got to stay. So just a little bit about myself and my education. I was a terrible student. I spent my childhood looking for ways to get into trouble, and I was usually pretty successful with that. But in high school, I was part of a program called DO, and it's called Diversified Occupations. And so what I did was I went to school in the morning and I worked the afternoon, which was fantastic because, not really, I'm joking. I say that I'm kind of the poster child for progressive education. I don't think going through school, I don't know that I ever read a book. I probably never read a fiction book until I was in my 30s. And so what Dr. Veith was talking about, that's what I was trained to be a worker. Yeah. And it's still in my blood. Yeah. You can't get it out. But so you're probably thinking to yourself, what did you do when you worked in the afternoon? Well, what I did in the afternoon is I worked at the Dog and Suds. Who has ever heard of Dog and Suds before? Shame on you. Anyway, it was a driving like A&W, that sort of thing. That's what I did. Let's see. But going through school, math class was always my favorite until I reached Algebra 2. And I had Algebra 2 with Miss Schmiedeskamp. And that's the last math class I ever took. And so you're thinking to yourself, why am I in here listening to this guy who never made it past Algebra 2 talk about math? And I'm asking the same question. Why are you in here listening to me? So as Erica talked about not being there yet, I'm not even close. After high school, I attended community college for a couple of years. I went to Northern Illinois University for a year, and I never graduated with a bachelor's degree. And I worked all kinds of jobs, from accounting jobs, computer operator, sales, delivery driver, and I was a catering truck driver. Remember that. I was a catering truck driver, because you're going to hear about that later, because I think it's very important. After graduating seminary, I have served at Mount Hope in Casper, Emmanuel in Alexandria, St. John in Petaluma, California, and St. Luke in Santa Rosa, California, and currently a middle school teacher at Memorial in Houston. So I'm honored to be here to speak to you about mathematics. My prayer is that is what I have to say to you may be a blessing to you and may offer some encouragement to you, and that there may be something useful for you as you prepare for this year and the years to come. Now, you may be asking yourself, what kind of conference speaking experience do you have? Well, I'm a noted and popular motivational speaker. I was invited a few years ago to at St. Luke in Santa Rosa to speak at their annual basketball camp. And I hear the chuckles. You're thinking about me speaking at a basketball camp. Now, to be clear, I never did play basketball because too short. I mean too tall, too fast. Really wasn't fair to the others. But I did have a career as a basketball player, and I don't know if any of you knew that or not. And if you do a internet search, you'll see some of my early photos. For those of you who are history people, here's one for you. Lenin for 3. And so I gave up basketball and I went straight into soccer, and that didn't go well either. So, but honestly, the funniest part of that is that I was asked to speak at a basketball camp. But anyway, teaching math in a classical Lutheran school, it's a beautiful thing, and I'm constantly telling that to my students as they groan and complain and moan. I tell them, look at this. Isn't this beautiful? So just as you know, when I was asked to do this, I was asked to prepare a one-sentence description for what this session would be about. And I said, well, how to make sure math class isn't stupid and boring. Now, and in spite of what I wrote, I see that most of you ignored that and you still decided to come anyway. But I heard through the grapevine that some people questioned this session description. I'm not going to mention any names, but I can give you names later. And if you think this is a joke, don't, because I have proof that this is true. Here they are working, and you see agenda item number 1 from Pastor Kieser is, what do we do with Gaub, and his session title, Stupid and Boring. I mean, you can see the concern on their face, and Pastor Paul looks, he's desperately trying to figure out something and trying to defend this choice. I don't know. So there you go. So we begin with a little poem by Carl Sandburg. Arithmetic is where numbers fly like pigeons in and out of your head. Arithmetic tells you how many you lose or win if you know how many you had before you lost or won. Arithmetic is 7-11, all good children go to heaven, or 5-6, bundle of sticks. Arithmetic is numbers you squeeze from your head to your hand to your pencil to your paper till you get the answer. Arithmetic is where the answer is right and everything is nice and you can look out of the window and see the blue sky. Or the answer is wrong and you have to start all over again and try again and see how it comes out this time. If you take a number and double it again and then double it a few more times, the number gets bigger and bigger and goes higher and higher, and only arithmetic can tell you what the number is when you decide to quit doubling. Arithmetic is where you have to multiply and you carry the multiplication table in your head and hope you won't lose it. If you have 2 animal crackers, one good and one bad, and you eat one and a striped zebra with streaks all over him eats the other, how many animal crackers will you have if somebody offers you 5, 6, 7, and you say no, 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 and you say nay, 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 and you say nix, nix, nix? If you ask your mother for 1 fried egg for breakfast and she gives you 2 fried eggs and you eat both of them, who is better in arithmetic, you or your mother? So we have all heard this before, that where students will say, I'm not good at math. I hate math class. I'm just not a math person. And math class is stupid and boring. And the challenge is to overcome this. Students come into my class or any class and know that I expect their attention and their hard work. The students are not permitted to tell me those things, that it's stupid, that it's boring, that they're not good at math. I tell them the complete opposite. I say, you are good at math, you just don't know it yet. And we do hear this quite often, which almost makes this satire seem like it's true. Now, it didn't necessarily work yesterday, so I have to change the display. This is a joke, by the way. But sometimes this seems like what we're dealing with. And hopefully we have enough sound.
Math? No. I do not believe in math, and I don't think we should encourage it. Oh, okay, this is a really hard one. There are really two sides to this story. On the one hand, you have math, and then on the other hand, you have, like, non-math. All 7-year-olds should have the right to decide for themselves if math is scientific fact. Math is a theory, and it's not at all what the Bible tells us. We live in America, not Russia. Just a little bit. Not, times. I think that people should try to be as knowledgeable as they can. I think they need to get learned so that, they can make a choice about all of the world things. Children have the right to learn anything they want to learn. Alchemy, ontology, gymnastics. You really don't know what the square root of 16 is. No one does. How to just make basic mixed drinks. This is math. I'm sorry, is this a joke? Creationism, whatever those Heaven's Gate people believed. Oh, and math. There are numbers everywhere. On phones, on houses, on microwaves. Numbers are great, but they should also learn colors, smells, vibrations. Math should just be left out of the equation. Not the equation like in a math sense, just equation, right? Because I don't believe in math, not to women. I guess if other people want to learn math, they should be able to. But then they'll be the type of people who know math.
All right. Anyway, but I do believe that we can make headway here and hopefully change some attitudes about math. But still, the students come into class many times without any motivation. I've heard questions like this: do we need our math books today? Well, I don't know, what class is it? Math? Then yes. Do we have to do math today? And so there have been a few times where the rebellion against learning math is almost seems like it's organized. And I've had this very thing happen in my class before. And I'll say, come on in, we've got work to do. And this is the response I get.
I don't really want to do the work today. I don't really want to do the work today. I don't really want to do the work today. I don't want to do the work today. What's this? Uh-oh. I don't really want to do the work today. I don't really want to do the work today. I don't really want to do the work today. I don't want to do the work today.
That really happens. So I like to, if you can't tell, I like to liven things up a little bit and use a few gimmicks to help the students remain engaged and focused. So for example, when we discuss the distributive property, we will I should probably have done this the other way around, but that's okay. We'll sing along. We'll sing along with Kermit. And you're going to say, why is he showing us this?
It took me a few weeks, but I ripped out my old myself.
Everybody knows this, right? It's what's it titled? The Rainbow Connection, right? And it's really depressing is when the students have no idea who this is. Yes. So you're thinking again to yourself, why in the world would you show that? And I really do show it. I really do. Is because we can have a problem like this. And even though I don't want to hear from any of you art people or whatever, I know this doesn't look like a rainbow, but we can diagram it, kind of like this, just used in different colors. And so the distributive property, we can call it the rainbow connection. Yes, yes. The study of the Pythagorean theorem gives us opportunity to visit the Wizard of Oz, and I tell them to watch this. And again, very depressing. They haven't the slightest idea what the Wizard of Oz is. They've never seen it before. They also don't. It really is depressing because we kind of have this generation that doesn't know this. They don't know the Lord of the Rings or Back to the Future. And these are very important things. Yes, yes. So I have them watch this and say, tell me what's wrong with this.
We have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Committee Artem e Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? That's Doctor of Thinkology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy! I'm gonna break! How can I ever thank you enough? Well, you can.
There you go. You can't. So I challenge them to tell me what's wrong with that. What is wrong with that? It's what? It's a right triangle, right? Yeah. And then when I have opportunity to point out the beauty of the power of 10, it's just like, just move the decimal point. That's all you got to do. You don't have to do anything. Just move the decimal point. Well, the power of 10, and again, this isn't really the only thing I can think of, so it's kind of corny, but... and you're thinking to yourself, corny? We haven't heard corny yet. Yeah, they get to listen to this. Because it's the power of 10, not the power of love. And of course, middle schoolers are, gross, love. So, yeah, I do make them listen to this. And they have no idea who Huey Lewis is.
I know who Huey Lewis is.
And they all have to sing along. All right. Sorry, I'll end the misery. There we go. All right. Oh, stop. See, that's the thing with Huey Lewis is he just won't go away, no matter how bad his music is. But I do love to teach math. In my classroom, you'll see quotations on the wall that are intended to set the tone for what is expected and for what they can accomplish. First and foremost is there are no shortcuts. That's actually taken from that book about a teacher from Los Angeles who wrote a book. There are no shortcuts. So if we're going to succeed in class, if we're going to succeed in life, there are no shortcuts. We must complete the job that we are tasked to do to our best ability, and that it's okay to get the wrong answer. It's okay to be wrong. As long as an honest effort is given, just guessing at an answer will not be accepted. That is a shortcut that's unacceptable. And this applies to teachers as well. No shortcuts, long hours, little pay, after school tutoring, whatever it takes to help the students succeed. The other one is the only easy day was yesterday. This is especially true in math class, but in any subject area as we build on what we've learned in the past. So in a sense, each day should be a new challenge and a new opportunity for growth. And then, being in Houston, failure is not an option. A sign that I actually purchased at the Air and Space Museum in Washington. Failure is not an option. Houston, we have math problems. But you can solve them and you will not fail. Expectations are high. We need to give all of our students the tools they need to succeed. And this is easier said than done. So a couple of new ones that are going up this year. Choose the harder right rather than the easier wrong. They want the easier way. We all want the easier way. That's the way of our sinful nature. Many times it's easier to do the wrong thing, just guessing at an answer to a math problem, trying to take shortcuts where shortcuts are not there or they're inappropriate. So we must expect our students to do the right thing, even though it might be harder. It might take longer, and it might seem easier to do the wrong thing. And our students' choices must matter. So make it matter. And whatever you do, specifically for our purposes today in mathematics, whatever you do, make it matter. I'm going to go to, how do I do this? Is the presenter view the one where you have two up there? Is that it? All right. All right. So, math class is the best of times, it's the worst of times. But in math class, obviously we start with a question, and the students need time to struggle. How many math teachers are there in here? Everybody? I mean, don't you wish you had more time?
Yes.
Right?
Yes.
Yeah, I ask for that every year. So we need more time. And of course, every publisher thinks that that's the only subject that is taught the entire day, because each lesson would take you, 4 or 5 hours. Yes. You're not the answer key.
Yes.
And you need to say yes to your students' ideas. Even if they're wrong, let them figure it out, and let them play.
Yeah.
Einstein said play is the highest form of research. Now, I read this little book. I think I brought it. A Mathematician's Lament by Paul Lockhart. And in this book, it says how school cheats us out of our most fascinating and imaginative art form. Now, I don't agree with everything he wrote in there, but he does have some good points. So, mathematics is an art. It's the purest of the arts as well as the most misunderstood. Mathematics is wondering, it's playing, and it's amusing yourself with your imagination. So he gives the example of the area of a triangle. And we teach the area of a triangle is equal to 1/2 its base times its height. Right? And then we say, memorize this formula and then apply it over again in exercises. Lockhart says, gone is the thrill, the joy, even the pain and frustration of the creative act. Because really, at that point, there's not even a problem anymore. The question has been asked and answered at the same time. There is nothing left for the student to do. And so he gives an example of if you have a rectangle and you draw a triangle in the rectangle. And his example is, well, just look at this and tell me how much space is taken up by this triangle. You know, is it half? Is it a third? What is it? And let the students try and figure it out. And he says that one of his, I believe it's one of his 7th graders, then said, well, what if I just draw a line here? Now this shows me that, well, this is half of the whole thing. So it's dividing it in half, each side. So yes, that triangle is half of the rectangle. All right? His contention is that they've learned more by doing this than just giving them the formula. By removing the creative process and leaving only the results of that process, you virtually guarantee that no one will have any real engagement with the subject. It's like saying that Michelangelo created a beautiful sculpture without letting me see it. By concentrating on what and leaving out why, mathematics is reduced to an empty shell. The art is not in the truth, but in the explanation, the argument. Mathematics is the art of explanation. If you deny students the opportunity to engage in this activity, to pose their own problems, to make their own conjectures and discoveries, to be wrong, to be creatively frustrated, to have an inspiration, and to cobble together their own explanations and proofs, you deny them mathematics itself. And then he goes on to say, I'm complaining about the lack of mathematics in our mathematics classes. On page 38, he says, the saddest part of math reform are the attempts to make math interesting and relevant to kids' lives. You don't need to make math interesting. It's already more interesting than we can handle. And the glory of it is its complete irrelevance to our lives. That's why it's so fun. Attempts to present mathematics as relevant to daily life inevitably appear forced and contrived. You see, kids, if you know algebra, then you can figure out how old Maria is if we know that she is 2 years older than twice her age 7 years ago. As if anyone would ever have access to that ridiculous information and not her age. I mean, I don't know how many times we're looking at a problem and you're looking at it, it's like, this example is ridiculous. I may just come up with something else here because this is ridiculous. Algebra is not about daily life. It's about numbers and symmetry. And then on 45 and 46 is that mathematics is an art, and art should be taught by working artists, or if not, at least by people who appreciate the art form and can recognize it when they see it. It is not necessary that you learn music from a professional composer, but would you want yourself or your child to be taught by someone who doesn't even play an instrument and has never listened to a piece of music in their lives? Would you accept as an art teacher someone who has never picked up a pencil or set foot in a museum? No, I'm not saying that math teachers need to be professional mathematicians, far from it. But shouldn't they at least understand what mathematics is, be good at it, and enjoy doing it? He gives another example that I tried with my class. I gave them this assignment over spring break. And so they're their assignment was to find the shortest distance from A to B by touching the line once. So they can't just go straight across. They're not allowed to do that. But find the shortest distance from here to here, touching this line. And so you can see the wheels turning. Of course, I gave it over spring break, so everyone waited till Sunday at 4:30 in the afternoon. I was like, oh yeah, I got to do that stupid thing, right? But so it's like, well, okay, let me guess, and I'll try this, and I'll measure it. Well, you got to be pretty accurate with a ruler, right? Okay, well, let me try another one then and see. Well, maybe that one will work. Okay, well then, how will I ever really know, right? And so the answer, obviously, is to find the reflection of point B, is have the reflection of B, and the shortest distance between 2 points is a straight line. And so, therefore, this is our point right here. Because now that's our point, assuming that I line these up all, right? All right, because this is going to be the same length as this. I didn't have anybody get it. A couple people were kind of close, but just giving them that and letting them think and discover it. Second, I've read parts of this book. I have not read the whole thing, but my youngest has read the whole thing, and he tells me I need to finish it. But this, I believe, strikes at the heart of what I try to urge my students to do on a regular basis, and that is to think mathematically. So Jordan Ellenberg, How Not to Be Wrong, The Power of Mathematical Thinking. At the very beginning, he asked the question, when am I going to use this? I know this seems dull, but you never know. You might go into a field where it's really important to know these formulas. This is seldom satisfying to the student because it's a lie. 1 second. And so he writes, fortunately, there's a better answer. It goes something like this. Mathematics is not just a sequence of computations to be carried out by rote until your patience or stamina run out. Although it might seem that way from what you've been taught in courses called mathematics, those integrals are to mathematics as weight training and calisthenics are to soccer. If you want to play soccer, I mean really play at a competitive level, you've got to do a lot of boring, repetitive, apparently pointless drills. Do professional players ever use those drills? Well, you won't see anybody on the field curling a weight or zigzagging through traffic cones. But you do see players using the strength, speed, insight, and flexibility they've built up by doing those drills, week after tedious week. Learning those drills is part of learning soccer. If you want to play soccer for a living or even make the varsity team, you're going to be spending lots of boring weekends on the practice field. There's no other way. But now here's the good news. If the drills are too much for you to take, you can still play for fun with friends. You can enjoy the thrill of making a slick pass between defenders or scoring from distance just as much as pro athletes do. You'll be healthier and happier than you would be if you sat at home watching the professionals on TV. Mathematics is pretty much the same. You may not be aiming for a mathematically oriented career. That's fine, most people aren't. But you can still do math. You probably already are doing math, even if you don't call it that. Math is woven into the way we reason, and math makes you better at things. Knowing mathematics is like wearing a pair of X-ray specs that reveal hidden structures underneath the messy and chaotic surface of the world. Math is a science of not being wrong about things. It's techniques and habits hammered out by centuries of hard work and argument. With the tools of mathematics in hand, you can understand the world in a deeper, sounder, and more meaningful way. All you need is a coach, or even just a book, to teach you the rules and some basic tactics. I will be your coach. I will show you how. For reasons of time, this is seldom what I actually say in the classroom, but in a book, there's room to stretch out a little more. I hope to back up the grand claims I just made by showing you that the problems we think about every day, problems of politics, of medicine, of commerce, of theology, are shot through with mathematics. Understanding this gives you access to insights accessible by no other means. Even if I did give my student the full inspirational speech, she might, if she's really sharp, remain unconvinced. That sounds good, Professor, she'll say, but it's pretty abstract. You say that with mathematics at your disposal, you can get things right you'd otherwise get wrong? Well, what kind of things? Give me an actual example. At that point, I would tell her the story of Abraham Wald and the missing bullet holes.
Just tell a couple of stories tonight, one short and one long. And let me start with the short story. It's just one slide long. It's a story about a mathematician named Abraham Wald. He was a mathematician who was born in Hungary, works in Austria, has to flee Austria when the Germans take over, and ends up finally in New York City, a professor at Columbia. And during the war, he participates in an outfit called the Statistical Research Group, the SRG. I actually had never heard of this before I learned about it after writing this book. But it was a top secret installation where some of the top mathematicians and statisticians in the United States were working in the neighborhood of Columbia University in New York, were working on problems related to the conduct of the war, problems of a mathematical nature. So it was kind of like the Manhattan Project, except it was actually in Manhattan. And one day, a group of generals came to the SRG, and they came to Abraham Wald with a question. So we have a math problem for you. We have noticed that when our bombers and our fighters come back from flying missions over Germany, they kind of look like this. They're riddled with bullet holes. But the bullet holes are not arrayed evenly over the planes that are coming back. That's what we've noticed. There's more holes in the fuselage of the plane. There's fewer holes in the engine. Different parts of the plane have different number of bullets. And here's what we want to know. We need to figure out how to put the armor on the planes. This is a serious issue, right? Because if you put too much armor, the plane doesn't fly, and that's bad. If you put too little armor, the plane gets shot down, and that's bad. So they came to the SRG, the generals did, and said, we need to know how much more armor should we be putting on the parts of the plane that are getting hit more. Is there some kind of formula for this? Is there some kind of math equation that you math guys can do for us to solve this problem? And here's how the story ends. Wald says, no. He says, you have it completely wrong. You have to put the armor where the bullet holes are not. You have to armor the engines, not the fuselage. Why? Because it's not that the Germans can't hit your planes on the engines. It's that the planes that got hit on the engines are not the ones that are coming back from the mission. So is this a math story or not? I say that it is, not just because Abraham Wald was a mathematician, but because I think in some fundamental way he was really thinking mathematically. And the story is there to tell a lesson that to be a mathematician is not just to compute a formula, right? A machine can do that. Even in the 40s, like, machines could do that. The purpose of the mathematical way of thinking is not only to answer numerical questions, but also to ask the right questions, to interrogate the question that we're faced with, and ask what assumptions underlie it, and if those assumptions are reasonable. and sometimes to overturn the question entirely.
All right. So, I am constantly asking my students, does my answer make sense? We have to think mathematically, think logically. Does my answer make sense? I saw the smile. If a question is looking for the number of students that can be seated on a bus, the answer cannot be 27 buses. If a question is looking for the number of buses that are needed for X number of students, the answer cannot be 6.5 buses, because they don't make half buses. If a question is looking for the number of students that can be seated on a bus, the answer cannot be 38.5 students. Not only are we teaching these future school administrators that buses cannot be cut in half, which will save them some uncomfortable meetings with the school board, we're also teaching these future teachers that when we go on field trips, we cannot cut students in half to make them fit on the bus. So, mathematics saves lives. So in order to help my students begin and continue to think mathematically, when they come to me with a silly question, I simply tell them, get away from me. And I never want to talk to you again. Now, to be sure, this may cause you to have to meet with your headmaster, and I always hope that there's not a prospective family tour happening right outside my classroom, but in all honesty, it does happen. I do say those things. But first of all, you have to know your students. You have to know your students and know who can handle it and who cannot, because there are some that can't. Because they'll come up and they'll say, I need help with this. And I said, well, get away from me. You haven't even tried it yet. Yeah. You know? And if they come again, I said, well, you just guessed at this. Yeah. I said, I'm not speaking to you ever again. I'm going to throw you out of here. Go back and try it. And they know, they understand. They know what I'm saying and why I'm saying it. I will not help unless you have tried it yourself. I will not help if you are asking me something that I know for a fact that you already know the answer. And I will not tolerate lazy. So, practice, practice, practice. If I see that there's a skill that needs to be worked on, I use this program. I'm sure there are thousands of other ones. I kind of like this. I use the one it's called Infinite Pre-Algebra, and it's just a test and worksheet generator. So if there's something that needs to be worked on at the beginning of the year, I always am pounding in, adding and subtracting with my grade level, adding and subtracting of positive and negative numbers, because that always seems like that's an issue. So, and I especially use this after school tutoring sessions. And then this year I plan to use this periodically. It's called Math Make More. I just happened to come across it towards the end of the year. There's supposed to be like, real life math problems. So these are some examples from it. It's very inexpensive. Geometry. When creating a home theater, how big of a screen should you get for a wall when looking at a 60-inch TV? How much room will it actually take up on the wall? All right. This sort of things that are available with this. There's a math mystery crime case. Students will aid the police in solving fictitious crime case using math and graphing. The one I used last year was the probability of rock, paper, scissors. Is that right? Did I say that right? I usually mix it up and say rock, scissors, paper, and everyone laughs at me. And yeah. So anyway, it's and they really seem to enjoy it and get something out of it. And I think I used it on a day when half the class is away at basketball or something like that. 1 second here. All right. And then making change. I've long thought about buying coin changers for each of my students, that they hook on their belts and force them to add the cost of multiple items and make change in a quick and timely manner. Why? I used to drive a catering truck, and my livelihood depended upon my ability to look and know the prices, add them up, take the money, and make the proper change. Otherwise, I was going to lose business, and my family wouldn't be able to eat. And so I do credit that with a somewhat decent ability to do calculations in my head. I think it all goes back to this. Because when you pull up to a construction site and all the construction workers who have exactly whatever it is, 15 minutes for their break, they come, they grab it. If they're standing too long, they don't want to spend their break standing in line or having you trying to add something up. So I had to do that. And plus they're 3 times the size of me. Anyway, so I also tell my students that when I see them working at working at their careers behind the counter at McDonald's, that they cannot make change if they can't make change without their trusty cash register, then I'm coming over the counter after them. So they need to be able to do that. Let's see, what else do I have here? So I talked about adding and subtracting of positive and negative numbers. Everybody know this love-hate thing? No. It's positive is love and negative is hate. So if you love to love, well, that's love. But if you love to hate, well, that's hate. But if you hate to love, that's hate. But if you hate to hate, well, that's love. Right?
That's good.
Right? And then there's another one. Sorry, does somebody need that back?
No.
Yes? Sorry about that. I'm about running out of time, but I'm not going to stop. Okay? All right. The other one is turning it into heroes and villains. So positives are heroes, negatives are villains. So if a good thing happens to a hero, that's good. If a good thing happens to a villain, that's bad. If a bad thing happens to a hero, that's bad. But if a bad thing happens to a villain, that's good. Usually 2 wrongs don't make a right, but in this case, they do. Okay. All right. Actually, my son and I we have birthdays very close, and so we were just discussing how old would we be on other planets, and I found this so on this this site here where there's actually a worksheet that you can give students and they can figure out how old they are. I've never done it before, but there's kind of weird things that my son and I talk about, and when our next birthday would be if we lived on Saturn. Pastor Paul gave me this this little book in preparation for this, and I thank him for the gift. First, some interesting things. First million decimals of pi are comprised of roughly 100,000 each of 0 through 9. The first 144 digits of pi add up to 666. The height of an elephant from foot to shoulder is 2 times pi times the diameter of its foot. How many of you knew that? And how many of you do you really care? Nobody, right? You can impress your friends. You like that one, right? Okay, you impress your friends at the next party, right? Is he allowed to go to parties? Okay, you can go to parties. All right, you heard it, right? Next time you have to go. Now, I wish I could recollect pi. Eureka, cried the great inventor. Christmas pudding, Christmas pie is the problem's very center. And so the number of letters in each word are the numbers, the first 20 decimals in pi. All right. I only get 1 session, so I'm going. I'm still going. All right. There's another little book, 50 mathematical ideas you really should know. There's a whole bunch of interesting stuff in there.
Who's the author?
Tony Crilly. So if you want any of this stuff, just email me and I will send it to you. I did not print anything out. All right. Our Gaub at mlchouston.org.
Thank you.
Okay. Closing thoughts. On October 21st, 2016, shortly before he passed away, Bill Heine sent me the following message. Melinda has been reading Salt, Light, and Signs of the Times to me. It is a book by Ronald Stelzer about Alfred Rehwinkel. On page 160, Stelzer gives this description of a teacher. So I leave you with this to offer you some encouragement, I hope. A teacher is expected to be a hybrid of entertainer, orator, scholar, disciplinarian, communicator, motivator, father, and friend. He must function in all these capacities day after day at all hours of the day before the same captive audience, among whom lurk the skeptical, the restive, and the sleepy. And when all are assembled and the bell rings and the classroom door shuts, he has no allies. He faces them alone. The man who measures up in every way to this job description does so only by an extravagant measure of God's grace. He cannot be paid what he is worth. He sent me that as a text message. I have never deleted it. And I thank you very much for your time. I appreciate it very much.